Our topic for the round table this evening, which is floods, the new landscape, could hardly be more topical. As some of you have already mentioned, we've been living through very wet times. The IPCC this week just came out with its new report, which has a lot about the impact of climate change being with us right now, and there's particular sections on the risk of flooding, both river flooding and sea level rising. And I just wanted to quote one section on coastal flooding from the report, which says, without adaptation, hundreds of millions of people will be affected by coastal flooding and will be displaced due to land loss by year 2100. The majority of those affected are from East, Southeast, and South Asia. So clearly, we've seen big floods in Asia, in Thailand, in Bangladesh, in China and Vietnam in the last couple of years. We've also seen serious flooding in Europe this year. In France, we've had flooding. In England, we've had serious flooding. My sister, who lives in south west England, she called me up this week, very excited, because for the first time since January, she's been able to go outside without her Wellington boots. It's been that bad. Of course, the list goes on. In Germany and Leipzig, we had bad floods last year. The Austrian section of the Danube was shut down for shipping because of the high water levels. So what we're going to discuss now for the next 45, 50 minutes are the questions of why is this happening? How much do we know and how much do we not know about the links between climate change and flooding? What are the implications for the insurance industry, both today and in the future? And perhaps most importantly, how can scientists and policymakers and business and the public work together to adapt to what seem to be very serious risks? We're fortunate to have a very interesting panel with 3 scientific speakers and 2 insurance experts on the issue. The scientists, I will be introducing them individually, are all supported, their work is all supported by the AXA Research Fund. And I'm going to start right away by first of all saying what we're going to do is we're going to give each of the panelists 5 minutes, no more, to make introductory remarks, and then we'll go over to a debate on some of the key questions that they're going to be raising. And the first speaker tonight is going to be Professor Colin Prentice from Imperial College in London, where he holds the chair in Biosphere and Climate Impacts that's funded by AXA. He's a very well-known climate change researcher who studies the land biosphere and has actually been working quite closely in the past with the IPCC. He has argued that the current state of knowledge about climate change impacts on ecosystems is actually inadequate. And Colin, perhaps you could start off by telling us what flooding patterns that you're observing in your current research.
I think it's worth beginning by saying that mentioning that a flood is not just a weather phenomenon; it's a human phenomenon as well. So when a natural floodplain floods, it's not a flood. But if the natural floodplain happens to have houses built on it, then it is. It sounds a bit trivial, but one consequence of that is if you have a change of rainfall patterns, it means that areas that are, increasing rain somewhere, then that somewhere is going to experience more floods. And we are seeing changes of rainfall patterns. There is a very robust global pattern. The areas where rainfall is currently abundant and heavy, it's becoming more abundant and heavier. And in certain areas that are currently dry, particularly Mediterranean climate regions, it's getting drier. This is what's been called the rich get richer phenomenon. And it's actually very well understood physically, and it's predicted by models as a consequence of human-caused climate change. So everything is consistent. And this is what's happening. Heavier rains are becoming more often, are becoming more common in those areas that experience rainfall. But it's not just the strength of the rain events or the amount of rainfall, it's also the persistence of weather patterns. And since I sat through the floods in the UK earlier this year, I know what was happening. It's not just that any one storm was particularly strong, it's that they kept on coming day after day and week after week. And this persistence pattern, it turns out that this is predicted by models as well. In other words, the storm tracks have been coming across southern England more frequently. This is predicted to happen more often. So although you can't say anything about what happens in one individual year, you can predict that we're going to see more of this sort of thing in the future.
Okay, so I would like to now turn to Uwe Ulbrich, who's our second speaker. He's the leading meteorologist at the Institute for Meteorology at the Freie Universität in Berlin. And his particular expertise is flooding. He notably studied the 2002 floods that damaged parts of the Elbe catchment. He's been developing a new methodology, which he may will talk about this evening, and he has called for a broader interdisciplinary approach to the study of flooding and flood damage. So, Uwe, I suppose the question is, should we be looking at river flooding as being somehow different from coastal flooding, or is there a commonality there?
Well, river flooding is a problem that has to do both with the atmosphere and the land surface and the river itself. And this is why different scientific disciplines are involved in this issue. And these different scientific disciplines have their own challenges. I'm from meteorology, so I do know very well that the current models that we have, they do have deficits. And we as meteorologists, we say, well, but we are quite satisfied. We are making forecasts that can be used and that give useful results. But once we give these results to the hydrologists who are investigating how a flood wave develops, they turn on us and say, your data that you are producing is useless. They are giving not the right results. They are not according to present-day climatology. And this is a problem once the different scientific disciplines are not talking to each other, and more of that, working together. Working together is one of these ideas that we had in this joint project with a colleague from hydrology. And so we developed a strategy that was designed to have the preconditions that are important for the regeneration and floods and the meteorological development and the probabilities that occur, they split in the first place and then brought together in order to have a better understanding of the risks. And we did this particularly for the Elbe basin. Once you speak about coastal flooding, of course, the joint cause of many of these floods, at least in Central Europe, is cyclones. The lows moving either from the Atlantic or, like we have it in the Elbe basin, quite frequently, cyclones that move from the Mediterranean up east of the Alps northward. And these cyclones have been identified for a long time as a main cause of major flooding events, not only in the Elbe, but also in the Oder and Vistula basin. And these, we have been investigating how they change and how they change in frequency in the climate simulations. And what comes out is, well, they decrease in number, which sounds fine, but once they produce rainfall, and they produce strong rainfall, then, because of the warmer temperature, we suppose, the intensity and the amount of rainfall is tending to increase. And so there is even a higher risk of more rare, but even more, well, effective events.
Okay, thank you very much. The third panelist is going to be Mathieu Chou, who is the head of the Natural Catastrophe Modeling team at AXA Group Risk Management. He joined AXA in 2006. He's a graduate of the École Polytechnique in Paris and holds a master's degree in climate modeling from McGill University in Montreal. Mathieu, what is the perspective on flooding from an insurance risk assessment point of view? Do you have the data you need to build strong models?
So first, first of all, there is a very crucial need for us to be able to understand our risks, and I mean our current risk, but also the risk we will suffer in the future. And when it comes to floods, it's a very big challenge for three main reasons. The first one, as Uwe Ulbricht just said, is that the source of the problem is numerous. We can think of river floods, flash floods outside of the rivers, flood coming from storms, or coastal floods following a storm, floods from hurricane, typhoon in Asia. So first, the nature is very difficult to model. Second point is that flood by nature is also a very localized peril, but in the same time, we can have floods that have widespread footprints, crossing many countries, as we saw recently in Eastern Europe. And the third reason why it's difficult to understand and model is that flood, of course, it's a matter of extreme events, such as the one in Paris in last century, but more recently in Thailand in 2011. So very massive extreme events, but in the same time, it can take the shape of much smaller events, but occurring many times in the year. So when you add up the losses, it can also be significant to an insurer. So faced with such a complex risk, of course, in the insurance industry, we already use models that we use to associate a probability with all kinds of losses we can suffer. And what I wanted to highlight is that those models, they have strongly evolved over time. In the past, maybe in the 80s or even 70s, insurers, they were using more statistical models where the basic idea was to collect claims from the past and then try to build very simple frequency severity model to extrapolate the losses. Now, it's much more connected with the academics, with the atmospheric sciences, etc., hydrology. We use physically based model where we are able to start from the precipitation, then convert it into a runoff on the ground, and then try to measure a water level, and finally a damage to the customer and a final loss to our portfolios. So it's a positive point that those models we use in insurance have been evolved like that. But still there is much to do to improve them. And maybe the main improvement will be to be able to extend the scope of those models. I'm thinking of Thailand in 2011 again, where at that time there were almost no model available, maybe because there were data missing, or because the risk was not well known. There was not a high risk awareness there, maybe. But then it's a fact that the risk was not modeled very well in 2011 in Thailand. And I think we can generalize to other countries in the world, like Asia, Latin America. But even in France, where we have a major country, some data, you may know that there is a state mechanism that is based on mutualization, and so that because of this solidarity, I would say it's not a big incentive to develop finest and the most reliable flood models locally. So we have still work to do even on France. And just maybe to conclude, I would say that research, of course, is very key for us to help us do our job, because only with better information and knowledge will we be able to better prevent and anticipate risks before they happen. In addition to, of course, continuing repairing for them after their occurrence.
Okay, thank you, Mathieu. I'm going to turn now to Professor Kerry See, who is an expert on natural hazards at Singapore's Nanyang Technical University, and you're heading up a new Geohazards Institute there. You're also the holder of the AXA Research Fund's first chair in Asia. Now, obviously, being based in Asia, you must be acutely aware of the flooding issues there. And you've been telling us that you've been working together with the Singapore authorities. You've also looked at the interrelation between your big speciality, which is earthquakes, and floods. And perhaps you'd like to start by telling us a little bit about that.
Actually, I think I've changed my mind. I think I'll start with something else. But I'll get back to that, okay? First, I want to confess to you all that I'm a strange version of Homo sapiens. I'm a geologist. So I have a different perspective than most folks in the sense that I think in short is 10,000 years. Okay? So one epoch. So our latest epoch is the Holocene. Okay? And the Holocene has been going on ever since we've had civilization. And in fact, agriculture only began when climate stabilized, about 10,000 years ago. So we've been living throughout our entire experience as civilized man during a time of climate stability, basically. So that's an important date in our history as a geologist. And as civilization, civilization didn't actually even begin to get a start until agriculture happened. So we could specialize, right, into being reporters or being insurance folks or being professors of ecology or being climate scientists at Lamont, right? So another important part of our history is about 6,000 years ago when sea level stabilized. The ice finally finished melting as much as it was going to, and so the coast became stable, basically. So that's when most communities like the Pearl River Delta in Hong Kong, many of the other deltas, New Orleans, for example, became possible. All right? So those two important things have now gone away. We've left the Holocene. We're now in what we geologists call the Anthropocene. That is, life according to man. Okay, so we are now leaving a big enough footprint on Earth that we're changing things enough that we'll be an important smudge in the layers when something looks back 10 million years from now. So with that context, let me just get back to Peter's original question. Sea level can change very, very abruptly, as well as very slowly. In some places that are tectonically active, communities have risen suddenly 2 meters. In the west coast of Sumatra, where I work, an earthquake resulted in the permanent uplift of several islands by about 2 meters. So imagine if you're a fisherman and all of a sudden your beach is half a kilometer out to sea and you've got to walk across a coral reef with your bare feet to get to your boat. Serious consequences. I would imagine you guys don't insure much of that, right? Small communities. In other parts of the region that I've been working, communities drop by a meter or so during these earthquakes, and suddenly your main street is below sea level during every high tide. So you suddenly become a Venice. Okay? Now, in most cases, this isn't a very important phenomenon in most parts of the world. Most major cities won't experience that. Instead, they'll experience a slow subsidence at 3 millimeters a year now. It was 2 millimeters a year back when I was born. It was 1 millimeter back at the time that Lafayette was helping us out in the 1700s. That's going to increase, and in fact, the projections are that by 2100, sea level will be something on the order of a meter higher. And in subsequent centuries, another meter, another meter, another meter. So most of what we know of the coast is going to disappear over the course of the next millennium. Actuaries who try to price premiums for insurance usually use the statistics of the past to forecast the future. That's not going to work, as Mathieu was alluding to, I think. As the average is increasing, the extremes change, right? So as I really appreciated what Dr. Sobel said a while ago, that the extreme events are the, what was it, cutting edge you said? No, it was the leading edge of climate change. So these extremes will be what get our attention, what show up in the news, what spur us on to political action. Let me turn a bit to that. In working in Singapore, I've seen a tremendous contrast between the way governments and people respond to the onset of the Anthropocene. In Singapore, I was asked, in the first year I was there, even not being a climate scientist, I was asked, Professor C, what should we do about sea level rise? We understand it's going to happen. Coming from America, where people don't believe in climate change still, I was quite astonished that I was being asked. my lack of expertise in that particular field notwithstanding. So I talked to my friends who do work on sea level, and I ended up recommending to the government that, you know, it's likely to be something about a meter or so. You better plan for a meter just in case. And so it turns out 6 months later, there was a public announcement that in fact, from now on, all new land in Singapore that is being built on will be raised 1 meter more than it was before, all coastal land. So quite an amazing visionary response. They bought themselves probably at least 50 years of time by doing that. You go across the South China Sea, the Sunda Shelf, and you go to Jakarta. Jakarta is a city twice the size of the entirety of Singapore. It's built on a delta, like Hong Kong, like Karachi, like New Orleans. And what is it doing about sea level rise? Well, what it's doing is it's meeting the occasion by sinking even more fast. Why is it doing that? It's pumping water out of the ground to serve its industrial and residential needs, and as a result, the sand beneath it is compacting more and more and more permanently. So there are parts of Jakarta that are not just meeting the sea at 3 millimeters per year, which is the global rate due to heating up of the ocean and melting of ice. It's actually subsiding. Half the city is going down at 6 centimeters a year or more. So multiply 6 centimeters by 90 years, 2100, and you end up with something like 5.5 meters. So half the town at this rate will be below sea level by 5 meters or more by 2100. So why the big difference in government and public response? I leave it to you guys to answer that question, because I know there are journalists here, and this may get out if I express an opinion, but there are clearly vast differences between the way communities are responding to what we Earth scientists, Earth system scientists, are talking about as we enter the Anthropocene. Thanks.
Okay, thank you. We're going to get now the insurance point of view from our final speaker is Vincent Lambert, who is the Chief Operating Officer of Global Business Line at AXA Global P&C. You've been in that job since 2012. And before that, he was the P&C Technical Director in Central and Eastern Europe and Chief Operating Officer at AXA in Belgium. Obviously, the flooding risks that we've been discussing are of major importance to the insurance industry. So from your perspective, can you talk us through the issue of how do you manage these issues?
Okay, thank you. So I confirm that the evolution of the weather catastrophe events is one of the most challenges we will have to face with in the future. And this could come as storms, cyclones, typhoons, droughts, earthquakes, including tsunami, and obviously floods. I just want to give you some figures. So in the 80s, there were approximately 125 large events a year. In the 19th, it was 250. And since few years, it is more than 400. So you see a very strong increase of the frequency of large events. And we have the same observation, the same evolution when we observe the total amount of costs. Over the last 20 years, we have an increase of 300% of the total amount of loss for the weather event, and more than 600% for the sum insured. We spoke on Thailand, just to give some figures. Thailand, it was $43 billion so losses, but only $16 billion insured losses. Austria, $3 billion. France, in 2010 to 11, $1 billion, sum insured. And as as it was mentioned, so we had this year and last year news large event in UK and in France. So anticipating of the evolution of these risks is key for the insurance industry. And as it was mentioned, not only examining the current situation, but putting a perspective in our approach. So how do we work, or what are our main concerns? So we have to understand the expected evolution of the risk using a more macro perspectives. This means not only considering the the frequency and the severity of this event linked to the climate change, but also looking to exogenous factors that can impact the consequence of a flood. I give you a few examples. In Highgrove Market, littoralization and urbanization. There are more and more people living in the city along the coast. So if you have a tsunami, you will have more and more damage. Another factor which is important is the penetration of the insurance. And there is a strong link between the level of the development of a country and the penetration of insurance. In a property risk, the penetration in a mature entity is approximately around 18-19%. In Highgrove Market, it's very often lower than 10%. And we know that this rate will increase in the future. So it's important to integrate all this, I would say, this consideration in our understanding of the evolution of this phenomenon. So having in mind these different trends, we have to improve our technical knowledge and we have to build a modeling. So we are working with Mathieu, and I will not repeat what Mathieu explained you, but it's very important to introduce in our modeling a prospective assumption and not to work only based on the, I would say, the current situation. And then when we have defining, I would say, a risk map, we can overlay our portfolio on this map, and then we have a very good view on the flood exposure we have in our books. And with this information, we can do different things. And I will move from micro to micro things. So first, we should define the level and the type of risk we want to keep in our books according to our risk appetite. And we should optimize the reinsurance schemes, also our protection, having a global strategy, but I will say manage selectively country by country. We should also define global guidelines for our underwriters. Managing the risk accumulation is very important to have a very diversified portfolio, and so to bring information to an underwriter on the accumulation risk he should have in some places. We will also be able to give a fair price to our customer according to their risk profile. And finally, we will be able to manage, I will say, important prevention action. Prevention to the authorities by delivering rich information that can support, for example, the implementation of appropriate measures to better protect the household. That can also encourage the authorities to define risk area, flood risk area, where building new construction should be forbidden. But also prevention for customers and prospects by delivering information concerning these risk flood areas, by promoting prevention solutions that can be put in place when a flood occurs, or by delivering preventive alerts. So you see, the challenge is huge, it's large, because there are many dimensions, and technical one, customer one, and we try to address these different dimensions.
Okay, thank you very much. Well, we have about just over 20 minutes left to get into a deeper debate about some of these issues we've been discussing. I think the first question will be to the scientists on the panel, which is, how fast is our knowledge really evolving? Are we is the scientific progress in this whole flooding area accelerating, or are we running into obstacles, or where are we in terms of the speed of understanding what's going on? Colin, perhaps you'd like to talk about that.
I always find questions like that difficult because as scientists we'd always like things to go much faster than they do. I think, in terms of understanding the global patterns of hydrological change, the understanding is gradually improving, and of course this whole enterprise is very reliant on the development of high resolution computer models. And the models are not yet perfect, and sometimes I could wish that that the groups that develop them will pay more attention to the origin of the differences between them, because there are still differences. The IPCC impacts report that was published on Monday does draw attention to the fact, I mean, it sort of says what I said earlier, only at much greater length, but with much greater documentation. But it also does mention that there's still, first of all, considerable variation between catchments, even catchments in the same area, small catchments being especially vulnerable, but also still some persistent differences among models. We don't know quite where they're coming from.
Uwe, you have looked at the methodology and made some interesting suggestions there. Is methodology one of the things that's holding us back from our understanding?
Well, I think one of the things holding us back is still tradition, scientific tradition, and a lack of data. For example, with respect to damages, this is something that is partly available, I think, at the insurance, but not really. To my knowledge, things from old times are written down in books, and they need to be drawn out of the cellar in order to make them useful for scientific evaluations. Though collaboration, this is what I mentioned before, is important, it is not the only thing. We need to have some basic improvement or in the individual sciences as well. We know of the deficits, for example, of our current modeling and forecasts, and something must be done about that. There are programs around, but this is still a way. And maybe with respect to the climate change that was mentioned here, there is, of course, climate variability on a decadal timescale. That is, within 10 years, you could end up in a situation that you would expect, on average, only in 2100, and it might go down again. And there is programs around that do try to develop a decadal prediction. And I think this will become very useful to combine with the hydrological approaches and with the insurance approaches.
Okay, Kerry, as a geologist with a 10,000-year view, do you have a different idea of speed?
Actually, let me talk about a political problem we have with climate studies in Southeast Asia. We have many countries in the space of the United States in Southeast Asia. So we have Indonesia, Malaysia, Singapore, Laos, Cambodia, and so on. And basically, the meteorological agencies there don't share data very well. Now, they have all sorts of political reasons for doing that, but in fact, until that political logjam is broken, it's going to be very, very difficult, according to my climate scientist friends and colleagues, to really have robustly reliable models, even if we did understand all of the physics. So there are political aspects, too, that are hampering the speed with which we do our science.
Well, that leads us to what Mathieu was saying earlier on. I mean, Mathieu, from your perspective, what else do you need to be able to build better models? And how do you make them more reliable?
More data and more reliable data, for sure. I fully agree with what was said, that it's very difficult to access to damage, information on damage. But even on the hazard side, I think we have a good reference point, which is all the hazard data that relates to earthquake, topography, geological things. We have the US there, where that diffuse, I have the feeling at least, that they diffuse widely, openly, data on earthquakes, seismic zones, etc. On the climate side, it's much more difficult, particularly in Europe.
Vincent, I know that you have a pet peeve about the lack of reliability and how dangerous that is for the insurance industry.
I confirm what Mathieu explained. We need data for building the model. We need a risk map. We can buy sometimes risk map. We can build risk map based on our own experience, based on our own experience and on external data we should find in open source, for example. But we have also a lot of work to do with our internal data. I will be very basic, but just the address. The address is very often an issue in the insurance company, and to standardize the address and to have a very, very good level of precision with the address. And sometimes it's just impossible because there are no addresses. It's the case in the Gulf, for example. And And in addition of that, address is not enough because you need to have information concerning the perfect location of an apartment, for example. An apartment on the third floor is not the same profile of risk as the apartment for the ground floor for flood. Perhaps it's the same for an earthquake, but it's not the same for a flood. Mm. So you see, you need very precise data to be able to really assess the correct profile of the risk. And for that, we need to work on internal data, but also on external data.
Okay, so for the scientific community to be able to deliver better data, what's the obstacle here? Is it computing power, or is it knowledge of the actual physical phenomena? Colin?
By data, you mean predictions. Which is a different thing, of course. I know modelers sometimes talk about model data, which always makes me bristle a bit, because models don't produce data. But anyway, so what do we need to do better? So one of the answers that you often hear from this is we need even bigger computers. Now, this, to some extent, this is true because actually both climate modeling and earthquake modeling of seismic processes related to earthquakes, so they're probably the two most computationally demanding tasks known to man. They consume enormous amounts of time on the world's largest supercomputers, and indeed these fields have been driving the development of supercomputers, particularly in Japan. And the frustrating thing here is, yes, we really do need bigger and better computers, but there is currently so I would say that there is a tendency for the centers, the big centers that develop these models, to put all their efforts into the newest and biggest and best model with the highest resolution, with the result that whenever they get a new computer, within about 18 months it's completely full and booked up for the next 4 years. I'm not making this up. It really is like that. Allowing very little time for sort of experimenting with different model configurations and so on. So I think that perhaps a little bit of a change of culture. I'm not the only person who thinks this. A little bit of a change of culture might be beneficial.
Okay, Uwe.
Well, there is a reason for that. What we have been knowing about climate and climate development is that there is no such thing as deterministic climate. Climate is a probabilistic approach, and in order to understand it, we need to have to produce ensembles of runs. And this is the one thing: to have reliable ensembles, you need many runs. The other thing is you need, for several instances, a very high resolution. Well, a nice example is, for example, flash floods. You cannot find a flash flood with a model that has a 100-kilometer grid point distance. That is just impossible. So also for that, we need the better computers. But still, of course, you are right in saying more and better computers is not everything. We know there are deficits that are independent of resolution, and they must be assessed. We have parametrizations in these models that just give you the large-scale response of small-scale effects that are apparently not sufficient and not sufficient for every situation. And we must do research on improving them.
Kerry, did you want to add something?
Taking the other point of view, let me give you one example from my neck of the woods. Or two examples. Before 2004, there was not a scientist I know who would have forecast a giant tsunami in that location. Nobody in Thailand, on the west coast, in Phuket, nobody in Malaysia, nobody in Aceh thought this was plausible. It wasn't even in our minds, okay? And then it happened, and in fact, in some places, it was 35 meters high, okay, wiping out entire villages and so on. We didn't know anything about that. There were no data about it. Okay, no predecessor 100 years ago or 500 years ago or 1,000 years ago. Let's now move to Java, which is actually the most populous island in Southeast Asia and I guess in the world. We don't fundamentally have the information, the data about past events to know whether or not a giant tsunami could hit the south coast of Java, or for that matter, the north coast of Australia, which it faces. So fundamental lack of information. If we had the information, it would be probably a fairly simple computational exercise.
Okay, I want to pick up something that you said earlier, Kerry, about Singapore and what sounds like a very interesting sort of degree of cooperation with the authorities there. I'm just wondering, from the perspective of the others on the panel, where do you see the most useful opportunities to work together with governments on adaptation? Vincent, perhaps you wanted to address that.
But there are different areas where we can work with government. For example, I mentioned the definition of a flood risk area and a new policy that to avoid that we build new construction in this area. So, okay, we have to live with the past, but we can avoid that the future will be, I would say, more difficult because we continue to build construction where it's not justified to do it. We can also support authorities when they want to introduce a CatNat national system, and this system exists in France. They are studying now a system in UK, so we can bring our experience and advise the authority in this kind of work. But prevention is really key. If we observe what's happened last month in the Netherlands and in Belgium, so we had a very strong storm together with a high tide coefficient, and in some places the sea reached a new record, the level of the sea. And because they've built a temporary metallic or pneumatic walls along the coast, they have really limited the damage, and the damage was very, very low in comparison with what we should have expected if we compare with what's happened in the past. Just because they've taken this kind of temporary measure, and so there's prevention, and we can encourage the authorities to do that.
Colin, you've worked both in the UK and in Australia. Is there a big difference in the two, in terms of the scientific appreciation and working together with the scientific community?
I think that there's a slightly paradoxical difference, which is that in Australia, in a sense, is very, very dependent on its physical environment and very much at the mercy of its physical environment. So it has enormous climate variability, far greater than most parts of the world. Even without any climate change. It has hazards of bushfires and large areas that are severely short of water. And on top of that is climate change, and the continent is warming up, and there are more fires. The southwest, which is one of those Mediterranean areas that I talked about, has been drying out steadily over the last 30 years. So whereas some of the country has seen some major ups and downs in rainfall, the southwest is getting drier and drier. And if you work for the Western Australian government, you're not allowed to mention climate change. It's very odd, isn't it? And we now have a national government in Australia where, that basically is opposed to the idea of thinking about climate change and asserts that fires, for example, have nothing at all to do with climate. What can you say? I think by comparison, the British government, of course, likes to, for quite some years has liked to sort of position itself as a leader in climate change, and therefore, for whatever political reason that may be, is, I think, in my experience, is actually very willing to listen to scientists.
Uwe, in your work in Germany on the Elbe, have you had a lot of contact with local authorities? Do they understand the risks? Are they taking action? Are they asking you for advice?
Well, there is different initiatives from the German government to have a better climate information distributed to the local authorities. There's a climate service center. The German Weather Service has started to give more information away about climate, and it is becoming interested now. So there are a number of very good initiatives to get climate information across. There is one initiative that I feel is lacking, and I feel it is lacking in many countries. And maybe Britain is an exception there. And this is that many of these data that are around, they are treated as, well, private or as something that belongs to the assets of a specific company. For example, we have not just been doing research on floods, but also on windstorms, and it was only through the association of German insurers that from all companies data were collected, and we could use them really to have a broad picture, and nobody having to fear that it is financially dangerous that we are doing that. And so I think this is a task that can probably in the end only be done by the state, to collect all these data and to aggregate them so that there is no harm to anybody and they are becoming really useful.
Kerry, did you want to say anything more about your Singapore experience? Is it really the model that others should be following?
I don't think that would work in some places. Singapore is small. It has very good contact between constituents and visionary leaders. It has the opportunity, because of its size and its economic wealth, to engage with scientists on a regular basis and so on. Its democracy is not quite as chaotic as democracies in other more pluralistic societies. So I'm not sure that model could actually apply elsewhere. But larger countries, the size of the United States, the size of the European Union, Brazil, and so on, they have to figure out some way that democracy doesn't get in the way of making progress in understanding the future.
Okay. Well, we're running out of time, so we have really time for one more question, which is going to be looking at more at the insurance end of things again. So this is really for Vincent. What kind of prevention services could be developed and for the customers, for your clients? And where could the scientific community still help you out with doing that?
Well, we can put in place the different solution. We can start just giving general information about the risk areas. For example, in the industrial world, we can really support the enterprise to assess their risk and to define or to take some prevention measure. There is one initiative perhaps that will summarize all what we have discussed. It's a very a service that should be very interesting for our customer is to launch, I will say, early alerts when a flood should occur, and to be able to do that is really complex, because first I need to have a very precise knowledge on the position of the risk. I need to know not only the position, so the GPS position, but I need also to know, I will say, the location. Is it on the ground? Is it on the first, on the second floor? And I need a very good mapping of risk to be able to assess if there is a potential of flood or not, and when, at what time. And because imagine if I launch multiple false alerts to my customer, I will lose my credibility for the following one. That should be the good one. And at the opposite, if I forget to launch one alert, a needed alert, I will be killed on the social media. So really, to be able to launch this kind of service, I need to be precise, and to be precise, it's very difficult to do it.
Okay, well, if you go to the movies, you'll know that the best example of an early alert for flooding is now coming out of Hollywood. It's a movie called Noah with Russell Crowe, an early alert that worked very well for one customer, but not for anybody else. And with that, I just wanted to say thank you very much to our panelists, to Mathieu Chou, to Colin Prentice, to Kerry C, to Vincent Lambert, and to Uwe Ulbrich. And thank you for your attention. And I now pass the floor back to Véronique. Thank you.
So thank you very much for this very insightful presentation. So I heard a couple of things, in fact. I heard data. We need data. I heard computer. But I think what I heard mainly was also cultural change, and I think I love it very much. So I think that if we can combine these three dimensions, we may be able to solve the problem before 100 years. So thank you very much for these very insightful comments that you gave us. We are, and we want to understand this phenomena because we believe that this can have a tremendous impact for our customers, our distributors, and our employees. And I think that the way you linked it between research and insurance was a testimony to that. We know also that this will help us to design the best products and services. And we know that we have a tremendous challenge ahead of us. Part of this digital transformation is our ability to build simple products. And as you can imagine, insurers are always very good at building complex product, but complex product doesn't fit on a mobile application. So we need also to reinvent ourselves to be able to send the accurate information or the accurate alert to our customers. And I think we have a lot of work ahead of us. What we have also is we have, and we want to do that, we have the willingness to also contribute to the global debate and to be able also to nurture and help by giving very insightful comments and knowledge to corporations, to governments, in order also to transform this model and make sure that we can prevent any big risk for our customers and our people. And I think that the role of the AXA Research Fund is definitely to support top-notch and top-tier global researchers, but also we want to be able to nurture the public debate. This roundtable was a very good illustration of the collaboration between academic and other experts that can help push the boundaries of knowledge further and improve the use of this knowledge for the benefit of the whole society. So I want to make sure that we can keep the momentum and we can all benefit from the fact that we have very prestigious people within this place tonight and that we can exchange in a more detailed and in a more approachable manner during the cocktail. So what I want to do before that, I want to make sure that we can also celebrate other researchers which are in the room and who have not been able to come on stage. So I'm gonna make sure that I want to name all of them, and I hope they are in the room. I want to make sure that we can welcome Dr. Luciano Raso from IRSTA. Dr. Émile Nollet from the University of Provence in France. So please stand up. Dr. Bogdan Antonescu from the University of Manchester in the UK. Marion Clemens, University of California, Berkeley. Bravo. Professor Jean-Marc Talon from Paris School of Economics. Dr. Bianca Jupp, University of Cambridge, UK. Dr. Julie Laforie-Janvor from École Polytechnique. And Professor Étienne Beaulieu from INSERM. We'd like to thank you warmly for your contribution. And finally, I want also to thank the members of the scientific board for their dedication, their energy, and their passion in attracting and selecting the best academic partners. It's been a real pleasure and honor for me to host that event tonight. And I can tell you that it's maybe the best part of my job, and I feel very honored and humble when I attend these scientific boards meetings. I'm learning tremendously, and I think I'm also very proud of what AXA is doing for the research, for the society, and for the governments. So now it's time to cocktail. But before, I would like to ask all speakers, grantees, and members of the scientific board to come up to a family picture, and I want to make sure that we give them a big round of applause. Thank you very much.